Hi guys, welcome to your first recorded lesson with me, Mr. Bradley. We're doing KS3 structure and bonding, and we're going to start with a recap lesson of what we should have done in year 7, which is how to draw atoms and their basic structure. So the lesson is going to follow exactly the same as we should be used to by now. All you're going to need is something to write with, something to write on, and your attention span. Let's avoid any distractions, mobile phones, other windows, etc. Let's make sure our focus is on what we're doing now. So how to use this lesson. Firstly, when questions pop up, pause the video, have a go at those questions, unpause it, and the answers will pop up, which you can then pause again, check your answers, and then continue to play the video, okay? This is an interactive video. You don't just let it play through. You need to be pausing, having a go at the activities, checking answers, and so on. And again, pause and rewind, rewatch explanations as needed. I'm going to be going through things quite quickly, hopefully on here, so it doesn't drag on too long, so that gives people the opportunity to go through at their own pace. So if you need to go pause and rewind and rewatch it when you're having a go at the questions, that's absolutely fine. That's what these videos are for, so you can go back and rewatch. So we're going to start with some retrieval practice. Pause, have a go, then unpause, the answer will pop up and you can check. Okay guys, hopefully that went well with retrieval. We're going to crack on with the lesson now. So structure and bonding, this whole topic links from the start back to this periodic table of the elements, all of those elements that make up everything we see today. And we are going to look at how these different elements combine to form the compounds that we see around us. We're going to start with just drawing individual atoms. It is really helpful if you have a periodic table to hand with you. You can print one off the internet. You should have one in your SRBs. Just in case you don't have one, I'm going to put one up on the screen here so you can pause and rewind and come back to this if you need it. Hopefully that's clear. But if not, now we'll go under the camera and have a look at how to draw an atom. Okay guys, so we're going to start by drawing carbon. So this is linked to our periodic table. So carbon is one with the C, and our top number is a 12 and the bottom number is a 6. This top number tells us the number of subatomic particles that are in the nucleus of the atom, that center part. So number of subatomic particles in nucleus. The bottom number tells us how many of those are protons. So the number of protons. This is often referred to as the proton number. So we can use this to draw out our whole atom, that information, the 12 and the 6, all we need to know. So we have 12 subatomic particles in the nucleus, so I just need to draw 12 little particles in there. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The bottom number was a 6, which tells me 6 of them are going to be protons. So I'm just going to colour in 1, 2, 3, 4, 5, 6. So I've got 6 protons in there. Last part is the electrons orbiting around the outside. Now to work out that number, it's always going to be the same as your proton number. And we should remember back from last year that is because our overall charge on an atom is 0. So if I have 6 positive charges, 1, 2, 3, 4, 5, 6, those positive charges coming from the protons, then in order to have an overall charge of 0, I need exactly the same amount of electrons in order for them all to cancel out and give me an overall charge of 0. The first shell, or the first orbit of electrons, can only have 2. So there's my first 2. And then the shells after that can all take up to 8. I'm not going to need to fill up all 8, so I've only got 4 left over to balance out that charge. So that gives us a carbon atom. And we can just write next to it PEN. P is our number of protons, so 6, electrons 6, and the neutrons, we just need to double check and count up how many aren't coloured in. So I've got 1, 2, 3, 4, 5, 6. So that gives me the number of protons, electrons, and neutrons in a carbon atom. And I've got all that information straight from the periodic table. I'll do one more. So right at the beginning, we've got hydrogen. Number 1 and 1. So I've got 1 particle in the nucleus. 1 of those is a proton. So I've just got 1 proton. And in order to have an equal number of charges, protons and electrons are the same. And that is our hydrogen. Really nice and simple. So if I'm drawing out protons as 1, electrons as 1, and neutrons is 0. I didn't have any neutrons in there. There's just 1 atom or 1 subatomic particle in that atom. What I'd like you guys to do now is have a go. You can use the periodic table to do this. I'll flick it up, but I want you guys to have a go at drawing out some atoms yourselves. Okay, so just 5 atoms there. Have a go at drawing those out. Pause here, have a go at that, and then answers will pop up. Okay guys, so hopefully you got those right. Here's 2 for you to check now. Let's go back under the visualizer for our next step. Okay guys, so going forward, we're only going to be interested in the electron structure. We're not going to be drawing out the whole atom with that nucleus in there. We're just going to put this chemical symbol and then draw the electron structure around it. We still need to be aware those protons are still there, those neutrons are still there, the protons are still carrying that charge, but we're only going to draw out the electron structure just for simplicity of going forward in the topic. So if we take the example of lithium, we've got a mass number of 7 and a proton number of 3. So the only information we're really going to be taking out of that for drawing our electron structure is that 3. It tells us we've got 3 electrons to put in there. So instead of drawing a nucleus, I'm just going to draw the chemical symbol. The chemical symbol is just what's shown on the periodic table. Then around that, I've got to place 3 electrons. We're following exactly the same rules as we should already know. That first shell can have 2, which leaves us with 1 electron in the outermost shell. Okay, that's one way that we can have a go at doing this. Okay, so a shortcut we can use to draw these atoms without having to count out all the electrons and put them onto the shells is having a look at the period and the group that the chemical is in on the periodic table. The period is the rows and the group is the columns. Now, the period will tell me how many shells of electrons there are. The group tells me how many electrons are in the outermost shell. So let's take that example of lithium again. I can see my first row here, I've got hydrogen and helium. My second row is lithium. All right, it's in the second period. So period 2 just tells me it's going to have 2 shells of electron. It's in group 1, groups being the columns again. So group 1 tells me it's got 1 electron in the outer shell. And that's exactly what we found when we drew it out with the just counting out the 3 electrons. So each of these periods tells you the number of shells. So sodium is going to have 3 shells, potassium will have 4 shells, and then the group tells you how many electrons are in it. So these will all have 1 electron in their outermost shell. Nitrogen will have 5 and oxygen 6, and so on. Okay guys, I'd like you to use that method to draw electron structure of the following atoms. Okay, here are 4 of them for you to check. If you've got all 4 of these correct, then it's most likely that you've got the rest correct as well. That's all for today, guys. Thank you for listening. Thank you for having all those activities. I'm sure we all did really well, and I'll see you next time.